Okay, so the next thing I guess is the state of ONNX. So there's a link to the issue that Christian posted on our tracker, and I guess I'll turn it over to him so he can kind of describe what he and Peter have been doing recently.
Yeah, I'll try, and please interrupt if there's any question or anything. I'm absolutely by no means an expert in ONX. I'm just somebody who needed long-term serialization, and instead of inventing my own protocol, I was thinking, hey, there exists something, so let's make use of that and see if I can move quicker that way. But there is the package, which I think is, I mean, fully functional, except it maybe doesn't support a very big portion of the spec. But apart from that, I mean, you can import and export models, and as far as I know, they are kind of, you know, bit exact with the whatever was imported. So previously that depended on the now kind of defunct ONNX.jl, and recently Peter made a base ONNX, and I just made a branch to make sure that I could make use of it of this ONNX mutable. Maybe I need to go faster, I don't know. But that's the status. And then I think there are many ways to build it here. Maybe one can try to build a kind of big ecosystem around, you know, trying to make everything plug and play to different packages, or maybe we should try to keep it to fewer packages to be less confusing. And I don't know, I just put some random thoughts here about, you know, the various parts.
So is there like a first goal that you're pursuing, like an end-to-end example of importing a model? Or...
So the end-to-end example, I think that works already, right? So that's why I said this ONNX mutable is fully functional.
Okay.
What I don't like about it is a bit of a monolith. It doesn't invite to collaboration, or at least it doesn't seem to do that, because nobody has filed any PRs. I was thinking that if people wanted to use it, I would probably start to see some PRs with new operators and so on. So one thing I thought I could do something about that is maybe to break it into smaller pieces and at least get rid of some of the dependencies. I mean, it depends on a library that I made that is maybe not the canonical Flux library really, and maybe when people see that dependency, they get a bit skeptical. I don't know.
I'll just add like a 10,000 foot view, which is that FastAI is a repository of best practices, which makes it easy to build state-of-the-art stuff because you can just use all the best practices from FastAI. And certainly in Vision and NLP, using large pre-trained models from, you know, Google or Microsoft or whatever is best practice. So we should have the ability to use BERT if you're, or, you know, GPT 3 or whatever, if you're doing NLP, and I don't know what the right vision thing is nowadays, you know, but you should be able to use those, start with those models and then add your own tweaks on top.
So with the current state of ONNX mutable, can you do that for your work, Peter?
I don't know. I haven't been, the last couple of weeks have been busy for me in my real work, so I haven't had a chance to do anything much.
So I have tried to import a lot of vision models like ResNets and stuff like that, and everything I've tried worked, and of course if I try something and it doesn't work, I fix it. I haven't tried any NLP models, so there could be missing ops for that. So maybe that's another way to do it. We just stick with the ONNX mutable and we try to, you know, import models that are state of the art, and whatever fails, we fix it. That is another way.
And if you want to scrape off the top couple of layers of ResNet or whatever and replace it with your own different layers,
yeah, I mean, I think this naive NASFlux, I don't know how to pronounce that in English even. But that is basically made for that, because it's made for that to be convenient and sort of error free. It has a lot of this intelligence on what happens if the size changes. How do you propagate that correctly so that everything stays aligned, and you make a small change to the sort of overall model if you think of the model as a functional thing as possible. But as I said, it's maybe a bit of an odd dependency, and it's, I mean, I might as well be the only user of that package in the whole world. So in that sense, it might not feel as official to people as one would like to.
I think there's definitely use in having like tools for editing models, adding layers, putting on classification heads, changing the number of outputs. In a more general sense. I don't think it's specifically tied to importing and exporting ONNX models, but maybe for like a model building API.
Yeah, I mean, I would say that is what this naive NASFlux is. It's not really connected to importing. It's just that ONNX mutable happens to be depending on it. So that's, I mean, you get a model from that library. It has its own sort of model language, I mean, DAG representation, which, I mean, of course, is built on mutability in the sense that you can change sizes of layer and remove them and replace them and so on. That's what it's built for.
Yeah. So I didn't know actually that ONNX mutable was already working for like large vision models. I guess I'll try it out over the next few days, see if I have any errors. Do we have like, is there proper documentation?
Yeah,
actually,
I mean, it has a very simple API.
That's true.
So
it just works.
Yeah. I mean, assuming that you don't hit a model with some OP that is not implemented yet. And of course, then just file an issue and I'll fix it as soon as I can.
Okay. Well, that's pretty cool.
I think then a good testing ground, in addition to like the NLP stuff, would be the vision models that we've been trying to merge into Metalhead. So that's like a stale PR that I have just because I don't have time to work on it. We need to add some more models to it in order for that PR to get merged. But the other aspect of that is adding pre-trained weights for all of them. So at least for the ResNet varieties, if we can use ONNX mutable to read a pre-trained model from PyTorch and then, you know, translate, because like Peter just mentioned, there's like a bottleneck and basic block and whatever in PyTorch that is not there in the Flux version. You know, we don't have any of those, or we chose not to have any custom layers like that. And so, you know, making that translation and storing the weights in the right places, I think that would be a good use case of what kind of model building utilities work and what doesn't.
So bottleneck blocks are an op in ONNX or in the PyTorch code? Because if it's not in ONNX, then it should be traced to just the low-level operations, right?
That's my understanding, but I'm no ONNX expert by any stretch of the imagination.
Okay.
Yeah, I don't think any of us are we?
Well, except maybe Christian, closer than any of us.
Yeah, I guess then we're in trouble if I'm the expert. But yeah, I mean, the spec is not that hard. I mean, it's just whatever you need to implement. You just find what the description is. How do you map it, and then you need to be creative. I mean, regarding OPs that are not in Flux, so far I had that kind of out of scope. If ONNX mutable gets a node proto and it finds fields in there which don't have an equivalence in Flux, it will throw an error. Of course, that can be fixed, and but it feels a bit ugly to have sort of basic layers defined in ONNX mutable. Then it becomes a kind of, if you want those layers, you need to also bring in all the import functionality. So maybe it's a better strategy than to add them to Flux. I don't know if there's any bottleneck with adding stuff to. Sorry.
one thing we might want to look at, which I just bugged the NNLib people about, is there's this issue about creating kind of an operation interface for NNLib. Let me see if I can find it. This one right here. So the idea being is that you abstract out all of your operations, which I guess we could try to match the Onyx operations to. So in this sense, you don't have to put any implementations in. You just say that this will return maybe like a functor or some sort of func that does this operation. And then the frameworks, because they implement the, like, what's the example they use? Linear bias activation, for example, will just run that automatically. So I don't know if this is the final design that they'll end up with, but at least it's an option. And I agree with your other option that you posted on an issue that I can't find right now, but about like worst case having the frameworks implemented, because that's exactly what happens in Python now, right? Like PyTorch has its own NX implementation. I think MXNet does as well. So it's not terrible. And I mean, if the frameworks don't have compatibility, that's kind of the status quo, right? Like I've seen more than a few PyTorch issues that say, oh yeah, this operator is not supported. And then angry comments about why they don't support ONNX. So I don't think it's too big of a problem. And it would be, if we're talking about reducing the size of ONNX mutable, taking the implementation out would be a pretty good first step there regardless.
So, I mean, I'm not in the loop, but maybe to those who worked on it, what do you think is the next step for the ONNX story? I mean, a lot of it already works. Do we need more documentation maybe? Or what do you think?
I mean, I think,
go ahead.
Sorry, go Peter.
No, I was going to say that for me, I don't know if it's the next step, but the goal would be a fast text demo of loading in some pre-trained models, scraping off the top layers, and retraining, retraining the top layers somehow. And then documentation surrounding that, explaining how to do each of the things would be a good short-term goal.
Use case similar to the FastAI tutorials, right?
Exactly.
Okay. Yeah. I think there's a lot of parts to that. I mean, for one, there's importing ONNX. Then there is the actual training, which flex training is mostly stable now, I think. But a big part, usually I find the biggest part is like the data pipeline and loading data sets, pre-processing it, augmenting it, decoding the outputs and all of that, which is always a hassle to implement. And I think actually that's like a big part of what FastAI provides, is that it gives you easy access to like data sets and augmentation, and you don't really have to mess with those too much.
For NLP, we could do something that doesn't require so much of that. You don't have to do too much for some of the NLP demo tutorials.
I think Vision might be an easier place to start though, because for NLP, you already have transformers.jl, which is already loading weights from, I don't remember if it's Torch Hub or whatever format or repository the Hugging Face models use, but those are being loaded in as like pickle objects already. But Metalhead obviously is pretty, its own life support, so that would be maybe easier to resuscitate. The NLP models use a more novel operations, I think.
Yeah, you're definitely going to have a smoother time using vision models with ONNX mutable as well. That's what I've been using most. I mean, I have not tried to import any NLP model.
Yeah, I mean, I guess to Lorenz's point, there's, for like the goal, the end-to-end example, that's made up of a lot more parts than just importing the pre-trained weights. And so maybe I think what we can do is on the tracker, create like a, I don't know, like a user stories folder where we, I mean, right now I can hear basically two types of stories. One is the NLP case and the other is the vision case. I know I have some stuff that we're going to hopefully get to today related to pruning that would be helpful for my work. So maybe if we could have like an example that we start writing in mix of markdown and I don't know, like a notebook or something, and maybe it doesn't all run, and maybe you hit some kind of thing that, oh, we don't have this functionality in Flux, and then that can help us direct our you know, next steps and things like that.
Do you know publish.jl?
Publish? Oh, yeah, is that what you use
Yes.
for all your docs?
Yeah, that's what I use. It's really nice, and it, also what you just said, Markdown and code mixed, actually supports like rigid programming in some sense.
Yeah,
So that would be
I mean, I've
one way
never
to go
used
about
it. I've never used it, but if someone wanted, if we set that up in the tracker repo under like a subfolder, then yeah, I think it would be nice. Because eventually, if we get those user stories working end to end, those can translate into tutorials for actual documentation on the repos.
Yeah, I've actually been wanting to write like an overview of all the parts that we need to build to have FastAI and like low level, medium level, high level parts. So like the training library, parallel data loading, data augmentation. Then I also once shared like deep learning tasks, like an interface for specifying like data pipelines. Something like that would be useful to then on top of that build like the what FastAI calls applications. So basically image classification, making it easy to use and also to train. And then also not another part like data sets, making it easy to I'm kind of giving like an overview of that and it's being done. I think it would be nice to have that documentation in one place, maybe at the tracker repo.
Yeah,
or at the FastAI repo.
Yeah, yeah. Yeah, I mean, the other thing I was going to bring up is, I guess, Dale, the reason, you know, you're here is because you wanted Monai, I think it's called, which is a library for ML and medical data. And so I think one of the ways that we can get started working on what you need, or you can get started on working on what you need for porting your research over to Flux, could be making that user story for one of your things that you already do in Monai and PyTorch. So like part of this discussion with user stories, if we had one that was your medical use case, then we can use that as a way to identify, you know, data augmentation or whatever kind of transformations you need for your pipeline.
Yeah, can you explain user story again?
So the idea would basically be almost like a tutorial, like a small example. And the reason I'm calling it a user story and not just a piece of example code is because, you know, you might have working code in there that runs, and then at this stage, there might also be stuff that doesn't run. So if there is something like, let's say, you need to be able to transform, or you need to be able to load some 3D image and apply some kind of transforms to it, some augmentation to it. and that's not something you can do right now, then instead of writing the code, you would write the task that you need to do and like describe it in English in terms of steps. And then that would basically be the prompt for us to go figure out what new repos need to be created or what issues need to be fixed in certain repos. And then as those get fixed, you would slowly replace the parts that don't work with the actual code that does work. And the goal being at the end, you would have kind of like a notebook or tutorial that someone else could follow and say, oh, here's how I load a 3D, 3D medical image data set and train it with UNet in Flux, if that makes sense.
Yeah, that's actually, I'll send in a link for one of the better Manai tutorials. That's kind of what I was actually hoping to do, is looking at Lorenzo's GitHub repositories. It seems like within like data augmentation, data or deep learning data sets, data loaders, things like that, you can kind of do, as long as we get it to the point where we have all the capabilities, seems like you'll be able to do everything Manai does. And then just for the training process, you would use FastAI for the learner step rather than writing out your own training process. Is that kind of what you're talking about?
Yeah, I think so. Yeah.
Yeah, it should be able to be built on the existing libraries. They will probably, I mean, you have to add the data sets by implementing the interfaces, probably maybe some augmentations as well that are not there yet. And then I think you can use Flux training probably to train it. If you want to, we can sit down together and go through it step by step. Not now, maybe over the coming days, but and see what still needs to be done. And then I think that would be a great way to get a like user story use case out of it and see what is missing, what we still need to build.
And my understanding of your points you put on Zulip, Dale, is that there's like that's all possible right now with all the libraries that are around, like Flux training, data augmentations, data loaders. I believe Daria, who's the main Flux maintainer, also has a UNet repository as well. So it's more a matter of like where certain code goes and who is responsible for it. For example, like certain augmentations I can imagine are not as appropriate for like a general CV augmentations library. Maybe that make more sense in like a dedicated medical imaging library, or as part of like a medical imaging augmentations. Likewise for all of the models, like UNet is, I guess, a general model, but I know there are some like augmented UNets that are used for segmentation that are very different specifically.
Yep.
And then obviously the medical data sets, maybe that should be its own library as well. But like I think this is a good segue into the augmentation talk as well, because having something we can point people to and say, this is the augmentation library that we're using moving forward, then you can rest assured that if you build stuff on top of it, it'll work with Flux training, with Flux in general, and all that.
Yeah, so I think, as you said, it's very important that we have like a core set of abstractions and interfaces for all kinds of stuff. For example, like a data augmentation library that already has, the most common things implemented. And then maybe for very special stuff, you wouldn't put it right in the base library, but make like a new library, or maybe put it in like a FastAI application. Same for like complicated training schemes. Maybe not, I mean, if it makes sense, but maybe not merge it into Flux training right away, but being able to create application-specific packages on top of those new core libraries, but also knowing that the interfaces are stable and kind of, I think that's where we need to go, and having those core libraries that you can depend on.
Did we settle on a, sorry.
Yeah, go ahead.
Did we settle on a programming model for the pipeline and parallelism? I know we talked about that last time, but like, it might affect the interfaces. So are we going with transducers? I don't know, or something like that.
I think it's possible. I wasn't there last time. I just read the minutes. Actually, I watched the video as well, but I think it's possible to make an API that's not too dependent on how it's built. I think, Kyle, you put into the minutes 2 ways of representing it in code, but they're functionally equivalent. I think the main thing is that we have some data containers using the learn-based interface, which is similar, for those who don't know, to the PyTorch datasets, where you basically implement how many samples are there and how do I get one sample. Quite simple. And then you just want to iterate over them in like an efficient way and have the transformations applied in parallel. So I think it's more like a low-level thing that can be implemented in different ways.
Yeah, I think, so the examples that were there was for like the data loading. I think Ari is asking beyond that or the next stage in the pipeline for augmentation. So last time we were talking about, I think there's augmentor.jl, there's your data augmentation.jl, and then there's also transducers.jl. And so I think, yeah, the question was, what should we build the data augmentation pipeline interface on top of?
Mm-hmm. Yeah. I mean, if it would help, I think I wrote a little bit about data augmentation on the Zulip channel, I think in the thread from the meeting. But maybe it'd be helpful if until the next meeting I a little bit of documentation that explains it and maybe the interfaces, and then we can see if what else maybe should be possible with it. Does it, just from the core abstractions, not actually from its implemented, because right now there's like no documentation except for doc strings.
Okay.
Would that be helpful?
Yeah, that would be helpful. I think then, at least for the data augmentation discussion, maybe what we can do is add that documentation to data augmentation.jl, and then all of us can look at that documentation, look at what the interface looks like, compare it against an alternate implementation if someone feels that they would like something different, like transducers. And for the use case aspect of that, I think if you and Dale end up, meeting up after this meeting or something to translate that Monai example to Flux, the augmentations in there, I think there's a bunch of them, I think would be, sufficient to really test if the interface is something that can work or not.
Yeah, and I think also maybe just collecting all the augmentations that are available in other libraries like FastAI, not even having to implement them, but just checking if does the interface, do the abstractions actually support that. So that we can be sure that it won't turn out like, oh, well, I want to do that, I cannot do it, I need a new library. That would be unfortunate.
Yeah, I can start another one another page on like the design docs and start listing those out, kind of like you did with the callbacks.
Mm-hmm. Yeah, that would be cool.
Okay, did anyone have anything else on augmentation, or should we move on to the next item? Okay, so I guess Lorenz, you want to, or you think Flux Training is ready for its first release?
Yeah, almost.
Woohoo.
Actually,
In which case, how do you feel about moving it over to the FluxML org?
yeah, sure, we can do that. That makes sense. I think. I mean, it's called Flux Training, so. Yeah. So I was wondering if it'd be possible to, or what would be needed to make it framework agnostic. But I think it would be possible with the current API. Well, no. Or close to it, but I think for now, having it be a Flux, I think it's sufficient.
Well, wouldn't that be a package called, I don't know, KNet training or something?
Well, I mean, just the thought was that if somebody wants to use a different deep learning framework or library, then they could use the same callbacks and everything and just put in a different model, different optimizer, and maybe set like a flag that please use KNet, similar to how Keras works, or at least used to work. I think used to work when it had like an MXNet backend or a Theano and TensorFlow or something. But I think that's maybe it's for now overkill and more maintainable this way.
Yeah, and I mean, we can always move it to another org again if we want to do that.
Yeah,
FluxML does have packages, or at least optimizers. Optimizers.jl, even though it's kind of in a stale state right now, I think part of the intention with that was that it would be a non-Flux specific optimization or optimizer package. And so, like, I know, like, if anyone subscribes to the Math Optimizations channel on Slack, I think Patrick, who's like the guy with all the optimization packages out there that are less ML focused, I think he has been in was in conversation with Mike when Mike started the whole optimizers.jl effort to bring like second order optimizers and things like that we don't typically use in ML, but still could be part of a generic framework like that. So point is that
I'm just saying that it has Flux in the name, so if
yeah. Oh yeah. So we can. I mean, we can change the name later down the line.
So who can move it actually?
I don't I think you can move it. I think there should, since you own it, there should be an option to move it to the org, and you're already part of the FluxML org. Okay, if you don't have that option, then we can ping Daria.
Yeah, of course. I would wait until the first release, but as right now I'm just pushing everything to master in this. I mean,
yeah, take your time
making governance.
Yeah, exactly.
Yeah, but I mean, the documentation is live, so if any of you want to test it out, you know, see if anything doesn't work, please tell me. It would be really nice to know that already. And also, if the documentation doesn't make sense or isn't clear, yeah, I mean, tell me, or better yet, open a pull request.
Once it's moved and we're happy with it, I think we should replace what's currently in FastAI with maybe just a single example or tutorial of using of doing something with Flux Training, so that FastAI becomes an umbrella, and this is the first thing we're going to put there, is just a simple training example.
Yeah, I think that's a good idea. And the documentation of all the various parts that we'll need to integrate into FastAI, I think it would also make sense for it to live there, so that people can maybe follow the progress as well if they go on the fastai.jl repo and find all the information here. Because I think just from the tracker repo, I don't think as many people would click on it to get like an overview. So we link a documentation page and that basically says, you know, this already works, we are still working on this, and what you can expect basically.
Exactly.
Okay, sounds good. I guess moving on to pruning, unless someone has anything else to add. Yeah, I didn't get a chance to, so I made a new tracker issue for like a pruning package. And I guess pruning is something that I do a lot whenever I do work with ML stuff. And so I was going to make the package. Right now, my main gripes with PyTorch's way of doing pruning is that you basically have to like iterate over all the parameters in your model, and PyTorch has like named parameters, so you have to give basically the parameter name as a string. In like it's like a array of like tuples that you have to basically construct and pass to the pruning method, and then yeah, it's basically annoying also to have to reform a pruned model and then unprune or like fix the pruning before you save it to disk. So it just makes checkpointing annoying and things like that, because if you save a pruned state instead of the fixed state, then you won't be able to load that checkpoint. So those are kind of the gripes I wanted to address. There's basically two ways I was thinking about designing it. One way basically being that or in both cases, you'd have, I guess, a prune function that would accept a model as an input and return a transformed model as an output. Now, one way that we could do it is the transform model returned is basically, basically a closure over whatever layer it was that you transformed, and then use Zygote's gradient tricks to define the gradient for that closure as reapplying the mask to the gradient before it gets applied to the actual model parameters itself. And so, the nice part about Zygote is that because we can do those kind of tricks with the gradient, you don't have to track kind of all this extra state that you normally do in PyTorch in order to be able to do the forward and backward pass of a pruned layer. So that's one option. And then the other way to do that is to basically define a new array type, which is the original array plus a mask, and then basically overload the get index and corresponding methods for that particular array type to apply the mask to the elements before it returns the item, and then the gradient of that get index operation will be will apply the mask to the gradient, basically. So you can either have the mask associated with each layer using a closure, or you can have the mask associated with the arrays themselves with a custom array type. And then I think Christian also pointed out on that issue that the NASLib library, which is basically built for mutating models, can support pruning. And pruning is one of the axes in some kind of neural architecture search algorithm anyways. So it would make sense to use that kind of library to do it. I mean, for like right now, the kind of pruning that I do is kind of like the standard pruning methods that you see in papers, but having a pruning method where things were optimized using jump or some other optimizer in Julia would, I think, be cool. And so having the package actually be able to support that as well would be a good goal. Yeah, I haven't written any code yet, but hopefully I write some code soon. Or at the very least, I'll definitely put my pseudocode ideas into more concrete thoughts on that issue.
I guess I could make an example of that as well with the ONX importer. Import a model and then prune it. And
exactly what I was thinking.
Yeah, that would be good. And I mean, yeah, maybe there's not really that much to put on top of what's already there in NASLib, right? Maybe it's just some things to make that whole loading and then pruning process a little bit easier.
Exactly. You might want to wrap it in a nicer API because it's not really meant to be used only for that. And I think maybe there's some convenience you can make to do something like, hey, find all the parameters that are worse than X and prune them instead of having to do that for yourself, looking through them and say, hey, reduce this layer by X and reduce that by Y. But I will make an experiment to see. There's a chance that can be done quite simply, actually, by just returning negative value for the parameters you want to prune. Something like, the value of the neurons is, their value minus the average value or something. And I will try that and see if it works. But there's a chance it won't because I haven't tried it. And just to be clear, I mean, then that's the structure pruning use case when the goal is to actually reduce the sizes of the arrays. I think you can do this unstructured with the mask as well, because there is an intermediate step before you apply the mutation where you actually change the sizes. There is an intermediate step where you just have some kind of metadata saying, what indexes shall I keep from each array and so on. And you could use that metadata to create a mask, but it could be a bit awkward. But all of that can, of course, be wrapped in an API if you'd like to use the library.
Okay. Yeah, and like I said, I'll have to explore the examples you already have for the library just to understand everything a bit more. Yeah.
I think both in Onyx and in the pruning here, we're going to begin to see the advantages of Julia. The fact that it's written in Julia all the way down as opposed to C libraries that you can't change.
Yeah, I think this is definitely a use case where we're going to look a lot better than PyTorch, at least in terms of usability and semantics.
And I bet the PyTorch pruning stuff doesn't work well with the PyTorch Onyx stuff. I bet, for example. And I don't remember seeing anything about pruning in FastAI either. So anyway.
Okay. I guess the last thing, this is the first time we're doing it, is the triage. My plan was to do it in the last 10 minutes, so we're approximately there. Let me post the first issue. Yeah, I guess the idea with this whole triage thing, I don't know if anyone's ever joined into the main Julia triage sessions, but it's basically very little talking, and mostly the idea is that we put the issue forward and we all look at it on our computer and go through it. And then, if you have a thought that like, oh, this issue is already fixed, this issue it can be fixed by this, then pipe up and say it. And then based on our comments, we'll know what to do next with how to resolve it.
I don't see the issue with recurrent neural nets here. The zygote issue, is that a different list?
You mean on the agenda?
Yeah. Or I'm just sorry, I'm looking at the page now.
I think I got the second issue should be that, but maybe I've linked to the wrong issue.
I think it's issue 12.
Yeah, issue 12 is the CRF last one. One thing I want to propose, assuming we have buy-in from the Flex owners. Don't you have the permissions, Kyle? Anyway, regardless, if we have buy-in, is to create a org-wide project for triage, because with org-wide projects in GitHub, what you can do is you can reference issues from any repository in the organization. So instead of having to create like the CRF issue, which is an issue that is just a forward pointer to another issue, you can just directly reference that issue as part of the triage project.
Yeah.
That sounds really good. Are there any blockers?
Getting someone to agree to create an issue in the FlexML org, I guess. That's all I can think of.
Oh, create the issue in the first place, you mean?
Or create the project in the first place.
I think I have the permissions.
You can move the project too.
Oh, okay. Yeah, I think I have the permissions to do that. I was just waiting for today's meeting, and I'm gonna double check with Daria just so that I'm not doing things to the entire org without his permission.
I was going to say just do it and he'll never know, but it's being recorded, so.
Okay, so I mean, I think at least on the two issues on the model zoo issue, there's two in the list that there isn't even an issue filed. So I think the easiest thing there is we can actually file an issue about that. Yeah, it does the add CI thing. Does that refer to basically having some kind of benchmarking? Brian, I think you wrote this issue, so I guess that was directed towards you.
Yeah, I think this was about, sorry, I was muted. This is about regression tests for all of the model zoo models so that they don't just die off every time there's a new Flex release or new CUDA release for that matter. It was discussed way back when, I think Daria mentioned it in a ML call many moons ago. And I don't know if there's still any appetite to do it, but I just wrote it there just for posterity's sake.
Yeah, I mean, I think we have the benchmarking project. So I think a long-term goal of that would be to use the model zoo as the benchmark, right? Because then the tutorials that everyone sees as like the first step tutorials will also be the ones that we're using to do performance regression. And so we won't have a use case where someone's new, tries Flux, and things train really slowly or don't train at all. So, I mean, for that stuff, I guess we have the longer term tracker issues. For the other smaller list of issues here, I don't know, should we maybe just link this list to or bring it up at the next committers call? Obviously, the best thing is if someone here, picks up the torch and goes to a couple of these issues and files a PR to fix them, just so that it can get merged and closed out.
Well, I think part of the, like a few of these are PRs, right? I think part of the triage was also light a fire under some of the committers as well, or at least show them that this is deemed important by the community. Like there are how many issues for upgrading Flux and upgrading CUDA in the Model Zoo right now? I think there are at least a dozen in different it's like a stratum, like a rock stratum. There are versions going all the way back to like Flux 0.10 and then up all the way up to Flux 0.11. And none of them have been merged that I know. So it's not even that people aren't putting in PRs, it's just that for whatever reason those PRs aren't translating into actual commits to the repo. But that's Model Zoo specific, obviously. It's not going to be the case for all triage items.
Right. I mean, maybe for this case with the Model Zoo, we can bring it up during the call and then see if they'll give some review responsibilities to some of us, you know, so that they can focus on reviewing PRs for Zygote or Flux, and we can focus on stuff like Metalhead or the Model Zoo or something like that. Yeah, I mean, I don't know exactly what process it takes for them to be like, okay, we trust this person to not screw up this repository, but at least it's worth bringing up. I think it's just a manpower issue for stuff like the Model Zoo. Basically, you see the word Model Zoo in the long list of notifications as a maintainer, and you probably just ignore it.
That's fair enough, yeah. In which case, then it should probably be archived or something. I mean, like this is part of the discussion, right? Of the triages. It's all about increasing community uptake and engagement. And if something is not working for that, then cut it off early before it starts, people start trying and getting burned and saying, okay, well, Julia obviously isn't ready for ML. Like, I'm out of here. I think that was part of why we started this call for context, right? There was a thread that we're kind of venting about all the issues with the existing ecosystem. And then lo and behold, now we're doing something about it. So.
Yeah, no, I agree. I guess on the CRF issue, Peter, that's basically your issue. What's the current state of the problem? I think you're muted.
Sorry about that. I'm unaware that anything has changed since the spring. From time to time, I try it and get the same problem. So in the spring, they gave me a workaround that fixed the CRF half, but didn't fix the recurrent neural net half. But you really wouldn't want to use the workaround that was suggested. You could see it in the issue there. So I was just waiting for them to fix, I guess, Zygote. I mean, I don't really understand why it doesn't work, but apparently Zygote doesn't like recurrent neural nets.
Okay, so I guess then maybe we can ask on the next committers call for an actual summary. So I was at the last committers call, and it was basically a situation where we had a call and then no real agenda beyond Keno giving an update on his AD stuff. And so I think if the next call is the same state, then these are things that can be the bulk of the discussion. And so yeah, maybe we can ask for like a update on the state of RNNs and zygotes and what are the major blocking issues for that.
Right. I mean, the text analysis package has a test that's failing because CRFs don't work with the current zygote. And we could certainly add a test that'll fail if you add an RNN into the world.
Okay. yeah, I guess we'll bring these up on the next call and see what, and I'll post on like the triage issues, I guess, the summary of what we just discussed at the meeting as an update.
Okay.
And then, yeah, bring it up on the next call and then update the triage based on whatever is said then.
If I can join the next call, I will. Hopefully.
Okay.
I'm
Yeah,
not
that
sure.
would be good because you know the
I-
issue better than me.
My sinking feeling is that the response is going to be wait for the new AD. But yeah, we should definitely ask about it, because if you tell us to wait, if they tell us to wait for the new AD, then the new AD better be out super quick now. If it can be fixed as I go.
Keno said
Hopefully.
that he's planning to release something in a couple weeks. That was a week ago. So I'm hopeful.
Cool.
Yeah, it's just, I mean, we have some transparency, but maybe we need more, is what I'm trying to say. Obviously, they're not
Actually, can
obligated
you
to
give
do
me
that.
like a
But
really quick rundown of the new AD, like what's happening? I'm not really in the loop regarding that.
Basically, there's an abstract interpreter interface into the Julia compiler that Keno added, and on top of that, I mean, I haven't read through the entirety of his write-ups, but he has a couple of write-ups that he's posted. If you look in the AutoDiff channel on Slack, I think you should find them, or just look in his gists on GitHub. But basically, abstracting away the process of taking a derivative, as a code transformation. I mean, using some category theory and stuff that I haven't read, so I'm not going to even try to explain it right now. But I think the main thing is that there's type inference that Zygote couldn't, or the compiler couldn't previously do with Zygote, that it now can do, and especially in the case of higher order derivatives. And so the new AD will help resolve some of the performance issues with Zygote that we've had, as well as, I guess, enable higher order derivatives, which is something that's not really well done in any framework. So hopefully whatever is released does work well. I don't know
faster, and faster first order derivatives. I mean,
yes, yeah, and faster first order derivatives.
And apparently, from what I hear, it's already faster than Zygote.
Woohoo! Great.
Yeah,
and hopefully less buggy.
Good. I'll check the Slack then.
Yeah, I mean, Zygote was built on like an accident. Apparently, that like the access to the compiler IR based on like generated functions was not something. It wasn't like intended for this, but like Keno just did like whole overhaul of the compiler infrastructure to support code transformations like AD, like GPU compilation, cassette stuff. It's going to go into like memory management. So this is exciting because it's like heralding a new era, like a new like foundation for all kinds of cool stuff for machine learning and beyond. So after 1.6.
Yeah, the only part of that I don't know is whether the new AD addresses the issue with mutating arrays in a gradient computation, which I think is the heart of a lot of the RNN issues, if I am remembering that correctly.
Yeah, that's a semantic thing, right?
I think Keno noted at some point that it would initially share some of the same failure modes as Zygote, but maybe I'm just misremembering that. there's also the risk that you mentioned that it won't make it for 1.6, which is also, we'll see. I mean, there's a lot of unknowns with this, so I think it's good to Kyle's and Peter's idea of asking about and working this out in the next ML call is probably the best way to go, regardless.
Yeah. I mean, on the last ML call, so there's multiple pieces to this. There's the abstract interpreter. There's this basic optics package, which is the category theory, transformation, abstraction stuff. And then there's the AD itself. And so, CR. So, yeah, I don't know which parts of those are going to make it into 1.6, but I know certainly Keno mentioned on the last committers call that parts of it would be pushed into 1.7. And so just because it could be, because it's a very significant change, so I don't think they want to rush it. But yeah, let's just ask and then see what the response is. I mean, if the response is wait for the next AD, then we should just ask, okay, so what should we do about all these issues that are out there? Someone should go through and type in wait for the next AD and close the issue, so that the person with the problem actually has some kind of response. Okay, I guess we're over time for sure. I'll try to allocate more time for this triage stuff if it ends up taking a lot of our meeting time. Okay, I guess thanks everyone. We'll talk to you in 2 weeks.
All right, thanks.
Thanks.
Very.
Bye.
Bye.
Nice to meet you guys.
Thanks.
See ya.
See ya.
Bye.